Okay, guys, recording a real quick video for you outside the dance room. You can see there's the weight room sign there. There's always kids in my dance room doing stuff. So our last lesson of our very first unit. Oh, we're here. So this is continuing to talk about projectile. I know we kind of took a break from projectile, but I wanted to kind of clarify a couple things in here. So we talk about a lot of things with projectile motion because there's three different things we could be looking at, right? The up and down motion, the side to side, or the actual motion along the trajectory. Right, again, that's the total speed we're talking about is along the trajectory, but we can break it down into a vertical and a horizontal. Again, think back to that Ironman example we talked about breaking down of diagonal speed. That's physically how it's working, right? If you can imagine someone pushing up and someone pushing sideways, we understand that the total or the result of that is going to be diagonal. So that's what we mean by breaking down a diagonal motion into the vertical and horizontal. So to be really careful when reading these problems about what they want. Now, we can use our normal kinematic equations with these situations. However, with gravity, you want to be really careful. We talked about how to designate your positives and negatives, right? You need to be specific. So usually, as a rule of thumb, if there's any initial upward velocity, so if I throw a ball and it starts going this way, yeah, what's going to happen is immediately gravity is going to start slowing that object down. So usually we call gravity negative in that case. Again, you could call it positive, but then you would need to be careful on your velocities. Yeah. If I'm going to go upwards to start, gravity is going to pull down opposite. And so we'd call it negative. Now, if you have a horizontal velocity, you can still call gravity negative if you'd like to. However, what's going to happen is if you just go out straight horizontal, you will immediately start speeding up. And so we can call gravity positive because we immediately start speeding up. Again, in this case, when you throw something upwards, you are immediately slowing down. So we can call gravity negative. Throwing straight horizontal, immediately we'll start speeding up. So we'll call gravity positive. Remember, it is your choice, but these are the standard kind of accepted normal ways to go about doing it. Okay, so other tips for projectile motion problems. Um, Depending on what you're trying to find, you might look at just the x component or just the y component. So, for example, where'd my blank go here? I think it's out of the way there. Time can only be determined in the y component because if we throw something, it's not going to hit the ground if there's no gravity, right? And gravity only acts in the y component. So trying to find the time of flight, you actually only look at the y component. Sometimes you need to solve for t in the y component, and then we can use it in x direction. For example, if I want to find the height, though, height of how far I'm dropping or something like that is still a y component thing, but distance is determined in the x direction. I might need to find the time in the y and then use it in the x direction, which gets confusing, as you can imagine. Because again, this is because gravity does not affect the x component of velocity. So usually, when I think about distance traveled in the x, there's no acceleration, and so we're not using a kinematic equation where there's a, right? A is in all of those. So we can think of the distance traveled by using the basic d equals rt. That's distance equals rate times time. That's like the algebra 1 version of distance, where your rate is your x velocity, right? X component of velocity, and then t is your time in the air. We're going to talk more about that in class, but it's very important to keep this stuff straight. It can get pretty confusing. So I want just one more time to trig practice here. As I'm out here outside the dance room, I'm going to write the setup, but then it's just a matter of plugging into the calculator to get the answer because I'm too lazy to plug in the calculator right now. So I want you to take a second and look at these two questions and see if you can answer both of them. It's just trig practice for breaking down a total velocity. Try and look at these questions. Morning. Just recording a quick video. They're all in there playing music. That's fine. I'll cut this part out later. Okay, let's do number one. So we have a cannon is shot out. The cannon itself is not shot out. A cannonball is shot out of the cannon, just throwing a cannon into the air. It's shot out with a velocity of 120 meters per second. So let's go ahead and draw a quick picture here. Wow, lots of stuff. Okay. Okay, so if it says a velocity of 120 meters per second, that's the total velocity. That is the diagonal hypotenuse, right? At an angle of 45 degrees up from the horizontal. So this is 120. I have a 45-degree angle here. Excuse my terrible labeling. This is my finger. And I want to find the vertical and horizontal velocity components. Again, this is the x and y velocity components. So here is my v x, or my vh, and my vy, or my vv for vertical. Yeah. So this is trig. Now, hopefully you recognize that because this is a 45-degree angle, your x and your y are going to be the same. So I can just solve for one of them, and then it's both. So if I'm going to solve for one of them, I can just pick which one. I'm going to go ahead and solve for Vy. Why not? That's my choice. So here's my angle of 45. That makes Vy the opposite, and 120 the hypotenuse. So normal trig, this is normal trig, not solving for an angle. That means you should have done sine 45, because with normal trig function's married to the angle. My y velocity over 120. That's my opposite over my hypotenuse. That's the SO and SOHCAHTOA, yeah. I'd multiply the 120 over. Now again, because this is a 45 triangle, your x and your y's are going to be the same. So whatever 120 times sine 45 is, that's going to get you your answer. And we can check that in class. I'm just too lazy to plug in the calculator here. Okay, number 2, Randy Johnson. The Diamondback picture from back when you guys were not even alive yet. Good Lord, I was in 4th grade. We won the World Series in 2001. Once pitched a ball at 45.5 meters per second, 102 miles per hour, at an angle 6 degrees above the horizontal. So once again, same thing, just practicing. Got a much smaller angle here, but we got 45.5 is the total. 6 degrees is going to be above the horizontal there. I have my x and my y, which is once again your vertical and your horizontal. You can think it that way. Okay, so this is my opposite. This is my adjacent to the 6. Again, excuse my very terrible writing here. So what that meant was you should have done for y, you should have done sine. For your x, you should have done cosine. So we've got Vy equals, nope. Well, I can do that because I've done this enough times, and we'll talk about that later. Hi! But I've got, sine 6 equals Vy over 45.5. Why did I put 0.4? And I've got cosine 6 equals Vx over 45.5. Should cross multiply to get the Vx and the Vy by itself. So again, plugging this in the calculator here, we would get that your y is going to be 45.5 sine 6, whatever that is, and your Vx is 45.5 cosine 6. This is going to be a very, very common setup here. We'll talk about that later. But again, plug those in the calculators. That's whatever you get. Okay, we're going to continue more with this in class. Just wanted to do a little bit more trig practice because a couple of us are still struggling with it. And then going over those first couple of blanks.